Can you believe it? Picture a cosmic event so colossal that it might cast shadows on Earth. Even in broad daylight, that's the scale of what could happen soon with Betelgeuse, a star in the Orion constellation that's been behaving unusually. Astronomers have observed signs that suggest Betelgeuse might be nearing the end of its life, poised to explode in a supernova that could illuminate our skies like never before. The question on everyone's mind: when will this grand event occur? What will it look like when it does? And what could it reveal about the mysteries of the universe? Let's take a deep dive into what's happening with Betelgeuse and how this might impact not just Earth, but possibly the entire solar system. Betelgeuse, situated approximately 650 light-years from Earth in the Orion constellation, is no ordinary star. This red supergiant is incredibly bright, over 100,000 times more luminous than our Sun. But it's not just the brightness that makes Betelgeuse significant, it holds a special place in human history and culture. The name Betelgeuse is derived from the Arabic phrase Yad al-Jawza, meaning the hand of Orion, and has been observed for centuries. Its reddish glow has guided travelers, intrigued astronomers, and captivated stargazers for generations. Imagine a star so massive that it could encompass our entire solar system. At roughly 10 million years old, Betelgeuse is much younger than our 4.6 billion-year-old Sun, but due to its massive size, it burns through its nuclear fuel at a much faster rate, leading to a significantly shorter lifespan. Now, as Betelgeuse nears the end of its life cycle, it stands on the verge of a spectacular finale, a supernova explosion that will unleash an unimaginable amount of energy and light. The last time Earth witnessed such a celestial spectacle was in 1604, when Kepler's supernova illuminated the night sky, remaining visible even during daylight for several weeks. Supernovae of Betelgeuse's magnitude are rare cosmic events, but when they occur, they leave behind remnants that offer scientists invaluable insights into the life and death cycles of massive stars. Recently, Betelgeuse has captured the attention of astronomers around the globe due to its erratic behavior. Between October 2019 and early 2023, Betelgeuse's brightness experienced significant dimming, causing astronomers to speculate on the possible causes. Although the star seemed to return to its normal brightness by April 2023, it once again shocked scientists when it surged in brightness by approximately 50% in the months that followed, leading to discussions and debates about its future. Could we be on the brink of witnessing one of the universe's most dramatic events, the explosive death of a star? The unpredictable fluctuations in Betelgeuse's brightness suggest that its end might be nearer than previously thought. Scientists continue to closely monitor the star, seeking clues that might unravel the mysteries of our cosmic neighborhood. But what's causing these sudden changes in brightness? Why would Betelgeuse, one of the most prominent stars in the night sky, suddenly display such unusual behavior? While stars may appear as simple twinkling points in the sky, they are dynamic entities, each with its unique life cycle, phases of activity, and intriguing mysteries. For many celestial bodies, periodic variations in brightness can be anticipated, much like the seasonal rhythms of Earth. Throughout its stellar lifetime, Betelgeuse has maintained a fairly consistent luminosity cycle of approximately 400 days. However, the significant dimming, often called the Great Dimming Event, marked a stark deviation from its usual behavior, challenging scientists' understanding of the star. At this point, you might wonder, are we on the verge of a monumental astronomical revelation? Though the exact reasons for Betelgeuse's erratic behavior remain under investigation, scientists have proposed several compelling theories. One such theory centers around stellar activity and mass ejection, suggesting that Betelgeuse may be experiencing events akin to massive stellar eruptions. Imagine Betelgeuse as a gigantic cosmic volcano suddenly erupting and expelling vast quantities of matter into space. Observations from the Hubble Space Telescope have revealed that Betelgeuse has, in fact, previously ejected enormous amounts of its surface material into the cosmos. This massive ejection, a staggering event, released roughly 400 billion times the typical amount of material expelled by our Sun in similar phenomena, an amount equivalent to several times the mass of our Moon. Such ejections can result in the formation of dense dust clouds around the star, affecting its apparent brightness and making it temporarily more difficult to observe from Earth. Once the dust cloud began to dissipate or was pushed away by radiation pressure from Betelgeuse, the star's normal brightness returned. This sequence of events offers a potential explanation for Betelgeuse's recent behavior, hinting at a star that may still hold many surprises. As scientists speculate on whether Betelgeuse is approaching the end of its life, many believe that a supernova may be in its near future. A supernova is an event of almost unimaginable power and explosion so intense that, for a brief time, it can outshine entire galaxies. This extraordinary phenomenon occurs when a significant shift takes place in a star's core. For some stars, this might happen when they accumulate too much mass from a nearby companion. In Betelgeuse's case, it's the gradual depletion of nuclear fuel that's creating instability, as the lack of fuel causes its core to collapse. But what actually drives a massive star like Betelgeuse to its inevitable demise? Stars such as Betelgeuse are born in dense regions of molecular clouds, where gravity pulls in gas, causing it to collapse and ignite a nuclear reaction that forms a star. In their main sequence phase, stars burn hydrogen in their cores, a process that lasts for millions or even billions of years, depending on the star's size. However, as stars consume their hydrogen fuel, they evolve and begin burning helium, leading to the formation of heavier elements like carbon and oxygen. For Betelgeuse, the transition from hydrogen to helium burning is a dramatic one, causing the star to expand into a red giant. Over time, as helium supplies dwindle, Betelgeuse has continued to evolve, shifting through stages in which it burns progressively heavier elements. The largest stars, such as Betelgeuse, experience these stages relatively quickly due to the enormous gravitational forces at play. The final stage arrives when iron begins to form in the core. Unlike lighter elements, iron doesn't release energy when it undergoes fusion. Consequently, the energy generated within the star is insufficient to counteract its own crushing gravity. The core collapses, triggering a massive rebound effect and resulting in a spectacular explosion, a supernova. So, is Betelgeuse on the cusp of such an explosive end, or is it simply biding its time? Recent research by scientists at Japan's Tohoku University suggests that Betelgeuse may currently be in its carbon-burning phase. Dr. Takashi Sayo, the study's lead researcher, hypothesizes that the star's core could collapse within a few decades once its carbon fuel is exhausted. However, not all scientists share this view. Other studies, including those conducted at Hungary's Konkoly Observatory, propose that Betelgeuse might still be in an earlier phase, specifically the helium-burning stage. Despite the ongoing debate, there's one point on which scientists agree: Betelgeuse is destined to become the next supernova in the Milky Way. Yet, predicting the exact timing of this event is a complex endeavor, with estimates ranging anywhere from the next few decades to 100,000 years. Amid all these scientific debates and speculations regarding Betelgeuse's fate, one undeniable truth remains: the nature of our observations is, in itself, a marvel. When we look up at the starry sky, we're witnessing a paradox, one deeply rooted in the relationship between time and light. Stars and other celestial bodies are so distant that the light they emit takes vast amounts of time to reach Earth. For example, even though light travels at an extraordinary speed of approximately 186,000 miles per second, the immense distances in space mean that the light we see from Betelgeuse today actually began its journey around 650 years ago. In essence, we're seeing Betelgeuse as it was centuries ago, a snapshot of its past. This vast delay in the transmission of light presents a peculiar challenge to astronomers by the time we observe any major event on Betelgeuse. It might have already happened hundreds of years ago. Thus, as we gaze up at this remarkable star, we're looking through a cosmic time window, marveling at its potential while acknowledging that we are merely witnesses to a past moment in an unfolding celestial drama. The speed of light, measured in meters per second, still has its limitations. Consequently, light from distant stars and galaxies takes a long time to traverse the vastness of space before it finally reaches us. When you gaze at stars like Betelgeuse, you're actually witnessing an event that occurred 650 years ago. To put that in perspective, when this light began its journey to Earth, the Renaissance was just beginning, and explorers like Marco Polo were leaving their mark on history. Every time we observe Betelgeuse, it's like looking through a cosmic time capsule, offering us glimpses into its distant past. Hypothetically, if Betelgeuse had already exploded in a massive supernova, we wouldn't be aware for another 650 years. So, while astronomers discuss and predict its potential supernova, somewhere out in the cosmos, this monumental event may have already occurred. We're simply waiting for that light to travel through space and time until it reaches our telescopes.